All right, so your test is going to cover 112 to 24. 112 was your transformations. Actually. All right, so I kind of like put all the parts in here, but we're going to talk about each of those parts and how they affect an equation. You're going to have to do this with an equation. You're going to have to do this with a graph. You're going to have to do this with a table, and you're going to have to do this with domain and range. Okay, so kind of like we did it when we actually did the lesson itself. If there is a positive or negative on the front, this is affecting your reflection over the x-axis, right? So if it's positive, it's normal. If it's negative, it flips it over the x-axis. Okay, that would be your reflection over the x-axis. If there's a number next to that, this is your vertical stretch or compression. And it is true, the scale is true to the value, right? So if it said 2, then it is by a scale of 2. If it says a half, then it's by a scale of a half. The vertical is true to what it says. If there is a number being multiplied inside the parentheses times the x, this is a horizontal dilation. So it's a horizontal stretch or compression. And this time it's the reciprocal. So if inside said 2x, that's a compression by a factor of 1/2. So the stretch is if it is in between 0 and 1, and the compression is if it's greater than 1. It's the opposite of the vertical shift, or the vertical dilation. Then came adding and subtracting inside the parentheses. And this is a horizontal shift. And in the opposite direction. If it's plus, we move left. If it's negative, we move right. And the last one is a vertical shift. If it's positive, up. If it's negative, down. Remember that these stretches and shrinks are also called dilations. So it might say vertical dilation instead of saying vertical stretch or vertical compression. Those are the same things. And it might say a horizontal dilation instead of a horizontal stretch or horizontal compression, but those are the same things. So in words, you can know it as dilation, but you still have to know how to find the factor. And then obviously, if you have a graph, you have to know how to shift those. If it's a vertical stretch, we take the y's and we change the y's. If it's a horizontal stretch, then we change the x's. Daniela. The only thing you have to do before anything else is the stretch or shrink. So the dilations come first.
Does that also apply in like the non-linear ones?
In the exponential, you mean? Mm-hmm. You won't really. So the exponential ones. So somebody asked us in the other class too. They're like, how are you going to know the difference between those two sections in the questions? These will literally say like, use the transformations to describe whatever it is, and it says like vertical dilation, that kind of stuff. And then your exponential stuff, like the ones we just did yesterday, it will say like what's the equivalent to it. So it's going to give you multiple choice, and you have to figure out which one's the equivalent. So because a 9x could be, or 9 to the x, could be a vertical stretch, or it could be a horizontal or shift. So instead of like you not knowing what it is, it will give you equivalence is basically what it will do. Yeah.
So you could say dilation or stretch.
That part is multiple choice and it will say dilation, but when you actually go to graph it, that's not multiple choice, or you adjust your domain and that kind of stuff, you need to know what it does.
Right.
Does that make sense? Yeah. But the wording on that is in multiple choice, it is dilation. Yep. And again, you're going to do this with equations. So like your f of x equals, and then you have to shift it. You're going to do this with a graph, where you get that weird graph and you have to move it around. You're going to do this with domain and range. And you're going to do this with a table of values. God bless you. Daniela.
What do you mean by reciprocal? Like when it's inside the.
So if it said f of x, well, g of x equals f of 2x minus 3. Let's say it says that. This is a horizontal dilation because it's inside the parentheses with it. And it would be to the reciprocal of that. So it's a horizontal dilation of 1/2, of a factor of 1/2. If it was 1/2 inside, it's a horizontal dilation of 2. But if the number on the front, let's say that's 4, that you keep the scale. So this is a vertical dilation of a factor of 4.
So it's a vertical stretch and a horizontal what?
This would be a horizontal. So if it's bigger than 1, it's a compression. If you take your x values and cut them in half, what's happening to it? It's getting closer to your y-axis. So it's compressed. Yep.
So we could do both?
Like this?
Yeah.
Sure. You'd have to move your x's and your y's. Okay. Yep. So this would be take your y's and multiply by 4. Mm-hmm. And this would be take your x's and multiply them by 1/2. And then this would be move the y's up 3 at the end. Mm-hmm. Yeah. Mm-hmm. Like, record this domain and ranges in interval notation. It will give it to you. Usually the domain is in parentheses and the range is in brackets, but whatever, it gives it to you and just keep it that way. And remember your domain, so the things that are going to affect domain are a left or right shift and a horizontal dilation and a reflection over the y. So those things are going to change your domain. Everything basically after the f. So anything that's happening in here is what's going to affect your, did I say your y? Your domain or your x. So if there's a negative here, I'm changing my x values. If it's a 3x, I'm changing the x values by multiplying by 1/3. If it's a plus or minus here, then I'm adding or subtracting from the x values. Yeah.
And what do you mean by like table of values?
A table of values looked like you had an x and a y. X, f of x, and you literally had your table of values, and it said like find f of 2x plus 1, let's say. So your and then it would say g. And then it would say find g of -1. And so you're going to plug it in. So I'd find g of -2. I'd go to my chart. -2 will be here somewhere. Let's say it's 3. And then at the end, I'm going to add the 1 to it. So my answer would be 4. Does that make sense? That's on the review. Yeah.
For interval notation, it's only for domain and range, right?
Yes. Yes.
How is g of -1 4?
So g of -1, if this is my g of x, I have to plug the -1 in, right? So this would become -2. And then I'd go to my chart and I'd find f of -2 or g of, f of -2, which is this one. And I get the y value, which is 3. And then at the end, I'm going to add the 1 to it. Does that make sense? Okay. Again, there's examples of all that stuff on your review. Yeah. Yes. Oh, let me finish range. So now range is affected by a vertical shift. So up or down. Okay, a vertical dilation. So something on the front of your parentheses. And a reflection over the x-axis. So all of this stuff happens outside the parentheses or before the f. So it would be like 2 f of x, a negative 2, minus 3, let's say. So this is going to flip my x values. I'm going to change all the signs. This is going to double my y values. Sorry, y. Double my y values, and then this is going to shift them all down 3 at the end. So the stuff that happens inside the parentheses affects your x. The stuff that happens outside the parentheses affects your y. And that's not to say you won't get one of both, right? You could get an x change and a y change. You just got to be careful. Again, there's an examples of that stuff on your review too. There's examples of all that stuff on the review. The review is long. I'll tell you, I'm going to warn you. It's like 40 questions. Some of them are fast, and you don't have to do it all. Like if you're really good at the increasing, decreasing when you get to exponential, I just gave you variations. That's all it is, okay? There's a lot of those, and then there's a lot of like, I don't know, when we get to there's multiple examples of what we did yesterday. So if you're good on that stuff, you don't have to do them all. But I wanted to give you as much practice as I could on that stuff. Sure. Questions on the rest of this stuff? So this is all 112. I mean, we did it again when we got to yesterday. We talked about horizontal shifts and dilations, but all of that was 112. And there's like one of each of those on your test. All right, then came 113. Let me just go to the next slide. And 113, try to remember the order. I don't know if I even put anything from 113 on there. Oh, maybe your piecewise functions. Okay, either the graph of the piecewise function or the actual f of x where you have to evaluate the piecewise function. We had done evaluate before, like if I gave you a piecewise function and I said find f of 5, you would have to know to go to where 5 falls in the range and give me the value. You could see a rate of change question there though, so like you have to find the f of the second one minus f of the first one over the second minus the first, that kind of thing. And then the new thing kind of with the graph was we talked about domain and range on those graphs, right? Remember if we're doing a piecewise function and it looks like solid, open, solid, open, solid, open. This is a step function, but something like that, okay? That if I am to list domain here, it would be from this value. So this is 1, 2, 3, 4, 5. It would be from 1 to 5 with a parentheses on the 5 because that's an open dot at the end. We're saying this is solid and this is open. And then your range values, you have to list because you're skipping the spaces in between. So if this is 2, 3, 4, 5, then my range gets a brace because I'm listing 2, 3, 4, 5. We had word problems like that, like find the value of f of blank and what does it mean in this context, like that kind of stuff came from that. Yep.
So we only list the range and not the domain.
Because domain goes left to right, right? Like if I'm going left to right, there are values from 1 to 2. So there's values from 1 to 2. This is an open dot, but this takes over. So there's also a value 2. If I keep going left, there are a solid dot from 1 to 5 left to right. But if you're going bottom to top, right, you get a y here, but then it skips. You get a y here, but then it skips, and that's why we list it.
Okay, thank you.
You're welcome. Questions on piecewise? Okay. Then 114 was the one you took your quiz on, okay? So this is where you're going to use your calculator. You're going to say what the model should be, and then you're going to give me the regression. And then it might say what's the value at this specific spot, and you're going to give me that value, okay? So for these, okay, you're talking linear, quadratic, or cubic. I didn't put quadratic on there.
Miss Cruz, how long is
Actually, I think it's a choice, so we'll add it on there, but yeah.
how long is this test?
It's 16 questions, but there's some with multiple parts. Yeah. Make sure you know how to find the the regressions. So you're going to give me the equation, f of x or y equals something, and then you're going to evaluate at a value. F of something. Yeah.
Are we gonna have like those real world problems?
Well, this is kind of that, but there will be some.
Like where we have to answer in terms of what the,
The restriction of domain and range.
like where it says like billions per year.
Oh, well, the unit might be there. Yeah. If the unit there, you include it, and then you would include it here. Yep. When he's done. Yeah. So also in this was your, actually, was it here? Or was the restricted domain? I don't know if that was in 13 or 14. Restricted domain, range, okay, where you have to think about your real world application. Something that has height can't have less than 0, right? So if it was quadratic, your minimum is 0, your maximum x value is where it hits the ground again. So 0 to 0, right? Like if it's this, then my domain goes from 0 to this point. Thank you. Thank you. You're welcome. You too. And then your range would be from 0 to the max. Something like area has to be greater than 0, right? Like you can't have something with 0 area. You can't have something with 0 volume, those kinds of things. Yeah.
Was that like with the graph?
This one gave you an equation and then you graphed it. Yep. So, and there's one on the review like that too. Yep.
And that would be the calculator.
That would be calculator portion. Yeah. So both of these calc. And I actually think that's in 113, but it's on the review. In 114, what was not on your quiz, which will come back again, is proportion. So if it is directly proportional, then we say y equals k times x. And if it's inversely proportional, we say y equals k over x. And then it will give you some scenario. And then you'll have to find the k. And then you'll have to get the second scenario. This is it. It was not on your quiz, but it is on your test.
Go back to the user.
All right, 2-1 was geometric and arithmetic. Sequences. So this is obviously arithmetic. You need AN equals A1 plus, God bless you, D, which is your common difference, times N minus 1. And your basic questions here are, here is either here are the terms and you have to figure out D and get an equation, or here is the first term and here's D, give me the equation, find this number term, find the 22nd term, whatever it is, where you're just plugging it in. Again, there's examples on your review. And then the ones where we jump, right? Like if I gave you A3 and I gave you A7, this time with the arithmetic, if you want to find your jump, there's two ways to do it. One is take whatever value. So I'm going to actually make these values so that we can. Something like that. I would do the second value minus the first over the second n minus the first. So you're finding the rate of change there. That's all. And that will give you D. I would go that route with arithmetic. I think it's easier. I think you're more used to a rate of change that way. The other way you can do it is by setting up an equation where you put the bigger base on the left. So A7 would go on the left. It would equal A3 plus D times the jump here, the second n minus the first n. So it would be plus 4D. And you can plug in your A7 and you can plug in your A3 and you can solve for D. Just remember every time you shift from arithmetic, so if I shift this, if I start with A2, then I subtract 2. If I start with A3, then I subtract 3. Okay, so those all shift. Then you had geometric. And AN equals A1 times R to the N minus 1 is your initial form. R is your common difference. And this time, if you're jumping, so you might get one that gives you the R and asks for a specific term. You might give one that gives you a couple of terms and it asks you to identify R and then find a specific term, something like that. And then you had the ones that jump. So if I gave you the fifth term, and again, if I gave you like the third term and the seventh term again, if I gave you these same three ones, but this time said it was geometric, I can't use rate of change. I have to use my equation, and I would do A7 equals A3 times R to the difference between those ends, which would be to the fourth. I picked really yucky numbers, but you get the point. It could be 27, it would be 25 equals 17 R to the fourth. I'd have to divide by 17, and I'd get the fourth root of 25 over 17 as my R. Sure. And then I could plug it back in. Yep.
You can leave it like that, or would you want to?
No, you can leave it like that. Yeah, and you'll see them on the review. They are not rationalized. Yep. Just remember, I could from here have to give an equation, and there's multiple answers for an equation. So if it's multiple choice, look for them. If it's more than one, obviously it will say select as many as, right? But if it was open-ended, I would take more than one answer, because you can either set it up with your A3, where it's AN equals A3 times R to the N minus 3. So it'd be AN equals 17 times the fourth root of 25 over 17 to the N minus 3. Or I can set it up with A7. So AN would equal A7 R to the N minus 7. And it would be AN equals 25 times the fourth root of 25 over 17 to the N minus 7. So if it was open-ended, I would have taken either of those. If it is multiple choice, you're obviously looking for just one of those. If it's multiple response, both of those could work. Yeah.
Is it R like a ratio or something like that?
Yeah.
Common difference, because like, wouldn't common difference be?
Oh, common ratio. Thank you. Common ratio. Kylie.
Would that be like a test question where there's like two answers? And
Could be. Right. It would say multiple response, so it would say select as many. Oh, yeah.
And like, is there most like there could be two, or should there be like?
I mean, technically, no, I could go backwards with these. I could say what would be A2, and A2, it would be cleaner. But A2 would be 17 divided by whatever my R is. And then I could say AN equals that thing times whatever the R is to the N minus 2. So it could go backwards. I actually think that happens on your review. You'll see it. It's just that the R is like 4 or something like that. It's not like that.
Would an R ever be negative?
An R cannot be negative. No. Still good. Okay, then in 2.2, we talked about geometric being exponential. Almost the same. The only difference is geometric has points and exponential would be a line. And we talked about linear. Actually, let me go in the same order. So arithmetic being like linear. Again, arithmetic would be points, linear would be a line. But that you could pretty much use the same. The questions, I think, from this section are relatively easy. It's going to like give you a set of data, whether it be points or a chart, and you have to determine if it's exponential or linear. Okay, so if it's exponential or geometric, you're looking at like a g of x equals 3 to the x. You're looking at a chart in which no matter if these increase by the same thing, these are being multiplied by a number. And in coordinate points, again, it would be the same. It would be an xy, where these are being, the y's are being multiplied by a number. Those would all be geometric or exponential. Linear, it would be in y equals mx plus v format. So where the m is your rate of change. Your chart would give you these points being equally distanced, and these you're adding or subtracting a number to get to the next one. Or coordinate points given in the same, these will be the same, and these you would be adding or subtracting the same number. The one thing you guys did struggle a little bit with on this one was the finding the, not so much with the linear, but finding the equation if you're given the coordinate points. So the linear, you have to find your slope, and then you do y equals mx plus b or point slope. For exponential, you have to find your rate of change or your r, and then you have to plug it in given what, so like if you're given, you have to use the formula we just did, where this is your n. So A2 is really 5, A6 is really 11, and then you have to do what we just did on the last geometric thing, where you'd have to do A6 equals A2 R to the 4 to find your R, and then you have to find your equation. And there would be more than one answer, because you could either use the equation with A2 being your initial one, or you could use the equation with A6 being the initial one. So that is like what we just did. It's just going to be delivered in different ways. Instead of it being in word problem format, it's going to be in coordinate points. Daniela.
Are you are they just gonna give you those 2 points and say find the equation?
So if it does say, if it gives you the 2 points, it will either say find it's a linear or it's exponential. You'll see it on the review. It's on there too. If it said, there's also one on the review that said, what could it be? And then that's where you're going to get multiple choice, where you have to figure out if it's arithmetic, it would be this. If it's geometric, it will be this. And you have to look for the right answer. Yeah.
So your initial doesn't have to be A1?
Correct.
Okay.
Good. Unless it specifically said use K as 1. Right.
Okay.
But I didn't do that. Okay. And then came 2, 3, which was exponential. So you have to be able to identify growth versus decay. Obviously, growth, the y grows, decay, it gets smaller. Growth is a base that is bigger than 1. Decay is in between 0 and 1. And then you're going to get a graph. Or no, you're not going to get the graph. You're going to have to answer, is it increasing or decreasing? Is it concave up or concave down? And what's the limit as it approaches negative infinity? And what's the limit as it approaches positive infinity? And you have a 33% chance there of getting that right? Because it's 0, negative infinity, or positive infinity. Those are your only options. Yeah. What do you mean? You don't, but that, you mean then it would flip it upside down? Yeah. You mean if it's here, like negative on the front? We did those. Inside it can't be, but technically that is, so if it just said negative 5x, this is on the front. Like that. So that would take your exponential and flip it upside down. We did do those, and they are on the review. Yeah. Questions on that? I think we're almost done, because then we're back to 2-4. And this will be, which of the following is equivalent? instead of you having to figure out, am I supposed to be doing this a horizontal dilation, a horizontal translation? Is it supposed to be vertical? Whatever it is, it will literally say, I don't know, like 16 to the x would also equal what? And so this could be 4 squared to the x, which would be 4 to the 2x, which causes a horizontal dilation, right? This would be a horizontal compression by a factor of a half. Or we could rewrite that as, if it said f of x was 4 to the x, let's say, I could rewrite this as, well, this would have been g of x. I could have written it as 4 times 4 to the x. Actually, it would be like this. Hang on. It would say something like that. Like if f of x is 4x, and then you get 64 times f of x. I'm going to say 64 times 4 to the x. 64 is 4 to what power? 4 to the third. So then this would be 4 to the x plus 3. And that would have been the choice from your multiple choice to match it with. So those are two different. One we did with the vertical stretch, which is the same thing as a horizontal dilation. And one we did with a vertical stretch, which is the same thing as a horizontal dilation. Yeah.
If that wasn't a multiple,
I mean a horizontal shift, sorry.
if that wasn't a multiple choice, could you also do two to the?
Yeah, that's why this one is, because there's a lot of variations. You could have made the base 2, and you could have made it 2 to the 4th. Yeah. So this one is multiple choice, and it is which is an equivalent. Mm-hmm. Like 2, 1.